Good morning, dear students. Myself Pushottam Pathak. Today I will explain you the chapter 2 of standard 8 maths, that is linear equation in one variable. In the previous class you had gone through the algebra and equations also. Come to the revision of those things once. Say constant you had learned. Constant where any numeric term 5, 7, 25 and so and were considered as constant. Variables were x, y or a, which could assign the value of any other number in the algebraic expressions, and while solving the equations, those are known as variable. Now algebraic expressions also you had learned. Say 2x plus 5. This was algebraic expression. If you take a particular 2x and 5, 2x is also one of the term of algebraic expression. 2x plus 5 and 5 is also one of the term of 2x plus 5. In this way, you used to make simple equations using the algebraic expressions also in the previous classes. Now, what is algebraic equations? Let us go through the algebraic equations once. Mathematical statement showing equality I have written the definition here. Algebraic equation, mathematical algebraic equation, not expression, equation. Mathematical statement showing equality between two algebraic expression is called algebraic equation. So take the example of algebraic equation. This is an algebraic expression 2x plus 7. If we write this is equal to 30, then we can call this the example of algebraic equation. Now come to the linear equation. Any algebraic expression, any algebraic equation in which the highest power of the terms, that is basically for the variables, if the highest power of the variable is 1, then that equation is known as algebraic linear equation, not algebraic, linear equation. come to the definition of linear equation. Write up the definition of linear equation also. An equation in which the highest power or exponent would be convoluted. Highest exponent of the variable is 1 is known as linear equation. Example: 7x plus 5 plus y is equal to 13 is linear equation. But if you write 3x square plus 5 equal to 78, very easily we can say this is not a linear equation, as the highest exponent we got here 2. If the exponent on variable is more than 1, that means if you can see the exponent, that means that is not the linear equation. Now come to the solving of linear equation. While solving the linear equation, some of the methods used are, say, the first method is say 2x plus 7 equal to 28. See how do I solve it? 2x plus 7 is there. To remove this 7, we can subtract 7 in the LHS. Similarly, we will subtract 7 in the RHS. Thereafter, this reduced to 2x in the next step, and this reduced to 28 minus 7, 21. In the minus 7, 21, 2x equal to 21. So to find out the value of x, if you divide this term by 2, then this 21 will also be divided by 2. To remove this 2, we need to divide the term by 2, and to balance the equation we have to divide 21 by 2. Now this 2 reduced to this term as x. So we can write here x equal to 21 minus 21 by 2. In this way, this was one of the method by adding, subtracting, multiplying and dividing both the sides by same number. The another method we had used in the previous classes also was transposing the number. How did we use this method? See, three x plus 5 equal to 17. In the next step, we used to transpose this 5 to the RHS. The things appearing in the RHS previously will appear again, and after that we will write up the numbers that would be convenient to solve the equations. Plus 5, now this plus 5 while going to the RHS will turn to the negative number. The positive number turn to the negative number and negative number will turn to the positive number. The number will be minus 5. Then in the next step we can write 3x equal to 17 minus 5, 12. Thereafter x equal to, see the relationship between 3 and x, 3 was multiplied. So when it will go to the RHS after transposing the number, we will divide 12 by 3. Therefore we got the number in x equal to 3, 4 is 12. X equal to 4. In this way, this was one of the method. Now I think you can solve the exercise 2.1. Come to the sum of the sums. I am showing you a few sums. See, in the exercise 2.1, the first sum is x minus 2 equal to 7. As I had shown you how to solve this equation, the simplest way was transposing the number. X equal to 7 appeared once again at its place, and this was minus 2 in the LHS. When it will be transposed to the RHS, plus 2. Therefore we can write x equal to 7 plus 2, 9. In this way you will solve the remaining sums. One more sum I am showing you. Take the 7 number sum. In the 7 number sum, it is 2x by 3 equal to 18. See the simplest way to solve this, as 2 by 3 appeared in the form of fraction multiplied by x. You can directly write here x equal to 18 into 2 by 3 will turn to 3 by 2, as both of the numbers are transposed now. Now reduce it to the lowest form. 2 9s are 18, and finally we can write therefore x equal to 9 3s are 27. In this way you can solve. I think remaining sums are easier to you. One more sum I would like to explain. Come through the twelve number sum. Not 28, it is page number is 25. Not once again, I have mistaken. 24, yes. the sum is x by 3 plus 1 equal to 7 by 15. See how to solve it. X by 3 plus 1. First of all, we will take this one to the RHS. X by 3 equal to 7 by 15 minus 1. Now, x by 3 equal to, if you take the LCM of both the numbers, or as you had learned in the fraction chapter, 15 was the 15, 7 was the 7, minus 150 is a 15, so 150 is a 15. X by 3 equal to 7 minus 15 by 15. In the next term, we will get x by 3 equal to 7 minus 15, that is minus 8 by 15. Now, simply you can write x equal to, now this 3 as it was, x was divided by 3, while transposing the 3 will be multiplied by the 8, that is minus 8 into 3 by 15. Calculate them. Minus 8 into 3 minus 24 by 15. In lack of space, I have written here. You can reduce it to the lowest term also. Here also it could have been reduced. As I did not reduce here it, I am reducing it here. Minus 8 by 5. This will be the solution of the equation. In this way you can solve the equation. In lack of space I have solved here. You will follow the proper way in your notebook and solve this exercise. In the next class I will explain you the next exercise also. Thank you very much.